Now we discuss the last step of analog to digital conversion, which is called coding. If you remember from our previous lectures, we have already learned about sampling and quantization. We know how to perform sampling and how to convert an analog signal into a discrete time signal. After quantization, the discrete time signal becomes a quantized signal. So now that we understand what a signal is and what a quantized signal is, we will perform coding on the quantized signal so that it becomes a digital signal. If you recall from the previous lecture, we had our quantized signal. In that quantized signal, we had 11 quantization levels. Coding is performed according to these quantization level values. Before understanding how coding is done, we must know the range of our quantized levels. In our case, all the quantized levels range from 0 to 1. So basically, from 0 inclusive up to 1, we have 11 quantized values. Now, we have to decide how many bits we should select for the coding format. Here, we must select at least 4 bits because a 3-bit code will not solve the problem. The reason is that for a 3-bit coder, from B0 to B2, we only get a total of 8 combinations, which means it can only cover the values from 0 to 0.7. You can observe that from 0 to 0.7, the last bit, or the most significant bit, is not sufficient to represent all values. So, if we use only 3 bits, it means we are not utilizing enough binary combinations to represent all 11 quantization levels that exist between 0 and 1. However, in this case, since we have 11 quantization levels ranging from 0 to 1, we must use a 4-bit code. This allows us to represent up to 16 possible levels, which is enough for our requirement. For example, if any quantized signal has a value of 0, its coding is 0000. If the signal has a quantized level of 0.1 after quantization, then its binary code is 0001. Similarly, if the quantized signal has an amplitude of 0.6, then its corresponding binary code is 0110. So, coding converts the quantized signal into a proper digital signal because we know that binary values are what computers can read and process. This is how we transform the quantized signal into a digital representation. Now, coding is usually not discussed in great detail in many textbooks because in most practical cases, we can perform digital processing directly on the quantized signal as well. However, it is important for you to understand how coding is actually performed because it is the simplest but essential step in the analog to digital conversion process. The selection of a coder depends on the availability of hardware and the specific requirements of your digital system. In our example, since the quantization levels range from 0 to 1 and there are 11 total levels, we need a minimum of 4 bits to represent them accurately. That is why we selected a 4-bit coder for this case. So, this was coding, the last and final step of our analog to digital conversion process.